So here are some more examples working with adding and subtracting radicals. Happy Wednesday. So again, what might help to find factor pairs if you can list the perfect squares. 1 times 1 is 1 squared. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5, 25. Then 6 squared. 7 squared, 8 squared, 9 squared, 10 squared. I mean, the list keeps going forever. I know I asked the list the first 15, but if you've remembered, I've been trying to keep these numbers reasonable and small. I don't foresee us seeing anything greater than 100. So keep in mind the idea when we're working with combining like terms with radicals, the numbers inside the radical signs need to be the same. If they are, we are in luck. So like this first example, number 1, we have here 6 square roots of 7 minus 4 square roots of 7. The square root of 7 stays. 6 minus 4 is 2. Likewise here, the square root of 6 stays. 8 minus 1 is 7. Where it gets a bit challenging is when we have to simplify the radicals. So it's really up to you. We know if we're going to be adding or subtracting, the numbers inside the radical signs need to be the same. So let's take a look at example number 3. Oh boy, I've got to break down the square root of 17 and 18. We're going to break both of them down, so a neat strategy to start with a smaller one. What are the two factor pairs of 18 where one's a perfect square? You got it, 9 and 2. So when I break down 18, I will get 3 square roots of 2. Use that to jumpstart your breakdown of 72. 2 times what gives me 72? You don't need a fancy graphing calculator. A basic 4 function will do. It turns out to be the perfect square of 36, and the square of 36 is 6. So now what do we do? Oh, we had a minus, subtract. 6 take away 3 gives us the final answer, 3 square roots of 2. Let's do another example just to make sure you got the hang of it. Let's take a look at example number 4. We have here the square root of 48 plus the square root of 75. We've done 75 over and over again. I know there are 3 quarters and 75 cents. So let's break that down using 25 and 3. And voila, we get 5 square roots of 3. So what about the 48? We'll take 48 and divide by 3 on a calculator, and guess what you get? You got it, the perfect square root 16. So we'll get here 4 square roots of 3. Go ahead now and add 4 and 5 to make 9 square roots of 3. So again, in summary, what you want to do when it comes time to adding, subtracting radicals is making sure that the numbers inside the radicals are the same. Now they do have some challenging ones, so let's take a look at one more to finish off our lesson for today. Look at example number 7. Oh my, there's a number in front of the square root of 8. No worries. Keep the 2 on hold and break down the 8. What are the 2 factor pairs of 8 where one of them is a perfect square? 4 and 2. So the square root of 4 is 2. We still have the 2 out in front. But is this 22? 22 square roots of 2? Maybe some of you wear 22 when you play CYO basketball? No, it's not 22. It's 2 times 2, right? So we get here 4 square roots of 2. Now don't forget, if we're trying to subtract these 2 radicals, we need to use the 2 to break down 32. So take 32, divide by 2, and what do you get? You got it, 16. So when you take, oh, I was about ready to show you what I've seen people do. When you take the square root of 16, you get 4 radical 2. Don't be tempted. I know the number 4 is a perfect square. Do I take the square root again? Is a question I got over and over again last school year. The answer is no. It's a one-time shot. But what happens when the 4 and the 4 subtract? You have nothing. Is it acceptable to write 0 square roots of 2? I mean, you may, but anything times 0 is 0. So hopefully this second video this week will help you when it comes time to adding, subtracting radicals and breaking down these radicals. And as you can see here, each of your answers do remain irrational.